suggested by Newmark's beta scheme has the following steps. The first step is related to initial conditions. So, it says form the K matrix, M matrix and C matrix, which we already know. The second step, initialize u0 and u dot 0 and compute u double dot 0. Third, select time step delta t and then the parameters alpha and del for the scheme. Fourth step, compute integration constants. There are many integration constants which are to be computed for the system. Del value should be greater than or equal to 0.5 and alpha should be greater than or equal to 0.25 of 0.5 plus del the whole square. So, A0, these are integration constants 1 by alpha delta t square, A1 alpha delta t, A2 1 by alpha delta t, A3 1 by 2 alpha minus 1, A4 del by alpha minus 1, A5 delta t by 2 del by alpha minus 2, A6 delta t 1 minus del and A7 del delta t. So, these are integration constants. Once I do this, I go to the fifth step. This says form effective stiffness matrix. Which I call as k hat, which is given by original k plus A0 m plus A1 c. Then triangularize k hat, that is k hat will be equal to L d L transpose. For each time step now, compute the effective load at new time step t plus delta t, that is f hat t plus delta t will be equal to f t plus delta t plus m times of A0 u t plus A2 u dot t plus A3 u double dot t plus c times of A1 u t plus A4 u dot t plus A5 u double dot t. The next step is solve for displacement at time t plus delta t, that is a new time step. So, L d L transpose u t plus delta t is f hat t plus delta t, because L d L transpose is actually equal to k hat. So, stiffness into displacement will give you the force. On the other hand, I can always say k hat u plus delta t is actually equal to f t plus delta t. So, I want u t plus delta t, that is the displacement at the new time step, is given by k hat inverse f t plus delta t. In the third step, compute acceleration and velocity at new time step t plus delta t, which can be given by u double dot t plus delta t is equal to a 0 u t plus delta t minus u t minus a 2 u dot t minus a 3 u double dot t, and the velocity at the new time step will be equal to u dot t plus a 6 u double dot t plus a 7 u double dot t plus delta t. So, that is the scheme available to us. Let us try to take an example problem and see how are you going to solve this. The example problem what I am going to take is a 2 degree freedom system simple problem, where the mass matrix is 2 0 0 1 and the stiffness matrix is 6 minus 2 and 4, and the force vector is given by 0 and 10. So, let us say u 0 u dot 0 is 0. So, you know m u double dot plus k u is f of t, where I am taking undamped system. So, one can say 2 0 0 1 of u 1 and u 2 plus 6 minus 2 4 of u 1 u 2 is 0 and 10. So, by this logic I can always find u 1 double dot and u 2 double dot by taking inverse of this matrix and multiplication, and I will get this value as 0 and 10. Please check this value, please check this answer by a simple mathematics, as we can simply multiply these two, okay, because this value is actually 0, is it not? This value is 0. So, I will take an inverse of this matrix and try to multiply with this vector, get this value. Okay. Check this answer. Once I get this, I want to perform important step. Okay. The important step is, you know, mass matrix is actually 2 0 0 1 and K matrix is 6 minus 2 and 4. One can easily use the existing computer programs which I gave you to find out the frequencies. So, let us do that. I will get omega 1 square as 2 and the corresponding phi 1 as 1 by root 3 and 1 by root 3. Similarly, omega 2 square is phi and the corresponding phi 2 I will get this as 0.5 root 2 by 3 and minus root 2 by 3. Therefore, I can get T 1 as 2 pi by omega 1, which is 2 pi by root 2, which is 4.443 seconds, and T 2 is 2 pi by root 5, which is 2.81 seconds. So, delta t should be actually equal to the ratio between these two values, which you take it as maybe delta t will be considered as 1/10 of the lowest period. I take it as 0.28 seconds in this example. We should also check that this delta t should be less than or equal to delta T CR. So, which should be T minimum by pi, that is 2.81 by pi, which becomes 0.9. Since delta T is less than delta T CR, the solution will be stable. Okay. So, we have ensured this. Once I do this, then let us calculate integration constants for alpha equals 0.25, for del equals 0.5 and delta t equals 0.28. So, A 0 is 1 by alpha delta t square, which is 1 by 0.25 0.28 square, which gives me 51.02. A 1 is del by alpha delta t, which is 0.5 by 0.25 of 0.28, which gives me 7.14. A 2 is 1 by alpha delta t, which is 1 by 0.25 and 0.28, which is 14.286, and A 3 is 1 by 2 alpha minus 1, 2 of 0.25 minus 1, which is 1, and A 4 is minus 1, which is 0.5 by 0.25 minus 1, which is 1. Again A 5 delta t by 2 del by alpha minus 2, which is 0.28 by 2, 0.5 by 0.25 minus 2, which becomes 0. A 6 is delta t 1 minus del, which is 0.28 1 minus 0.5, which is 0.14, and A 7 is del delta t, which is 0.5 into 0.28, which is 0.14. So, I got all the integration constants required for my numerical scheme. So, the next step could be compute k hat, which is k plus A 0 m plus A 1 c. So, this is 0 in my case. So, I should say is going to be 6 minus 2 minus 2 4 plus A 0 is 51.02 2001, which gives me k hat as 108.04 minus 2 55.02. I can use the standard subroutine to compute the inverse. So, I get k hat inverse as, you can check this value 0.0093, 0.00034, 0.00034 and 0.0182. I request you to please check this value before you proceed. It is a standard solution, you can obtain this. So, for each time step, we need to evaluate the following. Let us see what are they. We need to calculate f hat t plus delta t, which is the original f plus m times of 2001 of 51.02 u t plus 14.286 u dot t plus 1.0 u double dot t. Okay. Then we need to find k hat u t plus delta t is equal to f hat t plus delta t. Then one need to find out u double dot t plus delta t as 51.02 u t plus delta t minus u t minus 14.286 of u dot t minus 1.0 u double dot t. Then one need to also find out u dot t plus delta t as u dot t plus 0.14 u double dot t plus 0.14 u double dot t plus delta t. We need to know this. Okay. Let us quickly see how we can write a computer program for this and solve the problem using computer code. So, the same example is being considered now. You know, this is my mass matrix, this is my mass matrix, this is my stiffness matrix. I want to consider the system with the mass value, the damping value and the stiffness value, and that is my initial force vector. I am using alpha and del and delta t as you see from here. Okay. So, now let us enter the degree of freedom, which is 2. The mass matrix is entered and the stiffness matrix is entered and the damping matrix of course computed and entered in this example, okay, and the force vector is entered. Then let us verify this by printing the mass matrix, the stiffness matrix and the damping matrix. So, we need to give the inputs as degrees of freedom, mass matrix, stiffness, damping and force, what we did here. Okay. So, please check the units of mass and stiffness matrices and damping values before you enter. Okay. Be very careful about the units. Once I do this, then I do initial calculation. The following inputs are required. I need to give initial displacement, initial velocity. Initial displacement velocity is set to be 0 and I have to compute the initial acceleration, which I will compute later. Then I need to give the alpha and beta values which are entered here. The del value is referred as beta in the literature, that is why this method is called Newmark's beta method. Okay. You also decide the step size, that the delta t should be lesser than the delta t critical. Then you estimate what is the total time you require for calculating the response, in this case we have taken as 20. Okay. Then compute the initial acceleration vector which is required to solve the problem. So, this is computed from the original equation of motion. Once I do this, I now estimate the integration constants a0, a1, a2 and so on. Once I do this, then I compute the effective stiffness matrix, which is k hat using the equation. Then I find the final displacement, velocity and acceleration and keep on iterating it. So, calculate the displacement responses, then plot the values and try to understand how they vary. If you try to plot them, the mass matrix, the stiffness matrix and damping matrix are given as a sample output. This is the output at every 0.28, you get the plot value, the marker, and the total time taken is 10 seconds. If you try to do this for 100 seconds, you will see that initially for 10 seconds, the values are changing, then it becomes constant, then after a specific time it becomes completely unchangeable. So, steady stable output is available from the scheme. So, let us see the computer coding of this. So, this is my computer coding which we just now explained. So, we have entered the degrees of freedom, the mass matrix, the stiffness matrix and also the damping matrix. We have entered the initial force vector, we have computed and we have printed the mass matrix, the stiffness and damping for verification. we gave the initial displacement and velocity as 0, we computed the initial acceleration, we also fixed the alpha and beta value for the scheme, we also taken the time step, we want to do it for total 20 seconds, we calculated the integration constants, then we computed the k effective k hat matrix, then found out for a scheme of iteration the velocity, displacement and acceleration as you see in the scheme. If you look at the answers, we have plotted at every delta t value the steps at every 0.28. When we extended this for 100 seconds, you will see there is a steady stable solution available in the scheme. So, friends, in this lecture we understood how to solve an equation of motion using numerical scheme, what are the basic assumptions and analogy followed in this scheme, how to select or choose the time step for numerical integration, how to compute the critical time step so that the time step chosen is lesser than critical. So, to get a stable unconditional solution, we solved an example problem of 2 by 2 matrix and we found out that after a long iteration the solution becomes stable. So, the computer coding is available to solve this problem. So, one can try to repeat the solution by some other example and see how this can be comfortably followed by you. Thank you very much.